Example 4, dividing rational expressions. Dividing rational expressions is very similar to multiplying, okay? So what you need to do is you need to keep this one, change this to a multiplication sign, and flip the second fraction. Okay, so I'm going to keep this 4x cubed over 9x squared y, change this to a multiplication sign, and flip this upside down, do the reciprocal, so 9y over 5, or to the 5th over 16. Okay, now 4 times 9 is 36, and these aren't the same letters, so I'm just going to write them x cubed y 5. 9 times 16 makes 144. So 144, and we have x squared y. Okay, so now 36 and 144. If I plug that in my calculator, I get 1/4. Now we have 3 x's, and I'm taking away 2 of them, so that's 1, and that's a positive one, so it stays on top. 5 y's, I'm taking away that one, is 4, and that's still positive, so it stays on top. So that's our answer for this problem. This one, same thing. We're going to keep this one. We're going to change this and then flip this. So x squared over 4 times, and flip this upside down, 12y squared over x4y. If I multiply that straight across, my only number is 12, and then I've only got x squared and y squared. My only number is 4x to the 4y. If I simplify this, 12 divided by 4 is 3. 2 minus 4 makes a negative 2. So here's our first one. If it's a negative number, you're going to put it down here. But when you put it down there, you're going to make a positive. So 2 minus 1 makes a regular y, so just a y up here. And this is our answer right there. Here's another one. So once again, we need to keep this one, keep the first one. Times and flip this one, the second one. So flipping this upside down. You need a factor before you can multiply. So we have 5 x's and 3 here. So that's going to make, I need to take out an x to the 3rd. So if I take 5 minus 3 makes x squared. 3 minus 3 makes no x's, so just minus 4. That's the top part. This minus 2. We've got our x's for both. And then we have a minus 2 and a plus 1 to make that negative 1. So minus 2 plus 1. This is a perfect square. So x minus 1 and x plus 1. This one, once again, we've got multiple x's, so I can take out an x to the 3. And then if I take away 3, that's x squared. If I take away 3, that's x. If I take away 3, that's minus 2. So this one and this one still actually need to be factored. So that x cubed stays. But this is perfect, so x minus 2, x plus 2. Over this x minus 2, x plus 1. Times x minus 1, x plus 1. Over x cubed. And once again, this is an x minus 1, or x minus 2, x plus 1. So now what factors? or simplifies. This cancels with this. This x minus 2 is also here. That was a 1, I missed my 1. This x plus 1 is here. And I have nothing else that is similar. So this x plus 1 cannot cancel both of these out, only one of them. Okay, so on top we're left with x minus 2, or x plus 2 from here. X minus 1. Then x plus 1, x minus 2. So nothing is the same, so that is our final answer. Okay, same thing here. We have to factor this. So 2 times 4 makes 8. So that is 2x squared, and then to make an 8, make a negative 7, minus 8x plus 1x minus 4. If I group it, 2x, x minus 4, and there's a 1, x minus 4. So this is 2x plus 1 and an x minus 4. This is another one. I need to take out a number first though. There's a 4 that goes into each one. So that's 2x squared minus 7x plus 3. 2 times 3 is 6. So we have 2x squared minus, let's see, 6x minus 1x plus 3. So 2x goes into 2 and 6, so x minus 3 minus 1 and an x minus 3. Got 4, 2x minus 1, x minus 3. So I'm going to have 2x plus 1, x minus 4. And then x minus 3, x plus 3, times this one on top now, over 2x minus 1, 2x plus 1, and cancel. So we're left with this 4, x minus 4, or x plus 3. Try this one on your own.